Assalamualaikum and hello. I hope you are doing well. So now we are going to continue our second chapter, atoms, molecules and ions. So in this chapter, we are going to cover three subtopics. The first subtopic is proton number, nucleon number and isotope. And the second part, we are going to cover for atomic and molecular masses. And the last part, we are going to learn about nomenclature of inorganic compound. So in this video, I'm going to focus for the first subtopic, which is we are going to learn about how to describe proton, electron and neutrons as subatomic particles. And also you have to know how to define proton number, nucleon number and isotopes. And last but not least, you have to know how to write isotopic notation. So let's get into the first part of it. You have to understand what is an atom. So an atom is the smallest unit for any elements or any compounds. So what you have to know that in an atom there are three subatomic particles that you've already known about this before during your SPM level. There are proton, neutron and also electron. And for proton and neutrons, both of them are packed in a small nucleus at the center of an atom. And for electron, they move rapidly around the nucleus of an atom, as you can see from this picture. So this is the Bose atomic model, where it shows the three basic subatomic particles of an atom in a simple manner. But as you see here, this is your center of an atom, where you have neutron and also proton in the middle of it. However, you also got electron, which surrounds the center of the nucleus of an atom. In a simple way, you can see on your right side, this is the picture that you usually use during your SPM level. And you should know that the charge for the proton and electron is in opposite sign. So it means that electron has negative charge and proton has positive charge. However, neutrons have zero net charge. It means the charge is neutral. And you have to understand, at the center of an atom in the nucleus, since the opposite charges attract, that means that proton and electrons surrounded attract to one another. Okay? Next one, about three subatomic particles, you have to know a few characteristics of them, where their mass in terms of atomic mass unit, AMU, and you also have to know about charge in unit coulomb, and you also can know the charge in terms of units. So as you see here, I already give you the value for those number that you have to understand. And you need to know that 1 AMU is equal to 1.67 times 10 to the power of negative 27 kilogram. So now we are going to focus about isotope. So what is the definition for isotope? Isotope is two or more atoms. I need to emphasize here, two or more atoms of the same elements that have the same number of proton but different number of neutrons. So this is the full definition of isotope. You cannot leave any keywords yang saya highlight warna merah sebab you have to put in your definition. once you left one keyword, your definition will get 0. Okay, next one. What are the examples of isotope? I have here hydrogen, mercury, and also uranium. As you see here, isotopes will have the same number of proton. For example, here you see hydrogen, which is deuterium, D, has proton number 1, and the tritium, you got the proton number is also 1. So the proton number same, but the number of neutron is not the same, or the nucleon number not the same. Here 2 and 3 is referring to nucleon number, which means that these two are isotopes. Next one you can see mercury. So mercury, both mercury, we got same proton number 80, but we got different nucleon number, which is one of it 200 and another one is 202. So this is what I mean that isotope, they come from the same element but contain the same number of protons but different number of neutrons. Next one, saya ada a few examples. For example, saya ada lithium. So lithium, kita kenal dia sebagai simbol Li. So I got lithium where the number of proton all are the same, 3. But the nucleon number is different, 6, 7, and 8. But you have to understand also, I also got the isotopes for carbon here. I got carbon 12, carbon 13, and carbon 14. But the most usual or the most common that you've always heard about is carbon 12. And you need to know that isotopes have the same chemical properties but different physical properties. Why different physical properties? This is due to the mass number, which means that the mass of that isotope. So how you want to know the mass number? The mass number that we are referring right now is nucleon number. So now I'm going to focus the next part, which is about proton number. So proton number, the symbol is capital Z, and the other name for proton number is atomic number. So what is the definition for proton number? Proton number is a number of protons in the atomic nucleus. Please put the definition as this is, because if you left one keyword, you will not get full mark for the definition. Okay, this is the shortest definition that I can make for you. Okay, maybe you can see another different definition, but it brings the same definition, the number of protons in atomic nucleus. And the next one, you also will know about nucleon number. The symbol is capital A. So this is what I'm referring to, the number from the slide before. For lithium, you got lithium 6, lithium 7, and lithium 8. So 6, 8, 7 is nucleon number, or what we mentioned about their mass. So the other name for nucleon number is mass number. So what is the definition for nucleon number? Nucleon number is the number of protons and neutrons in the atomic nucleus. It means that the summation of protons and neutrons. So please be careful with the term. You can hear always about protons, electrons, neutrons, nucleon number. So make sure you know how to differentiate those words. So next one, What we're gonna do, once you already know about the definition for proton numbers and nucleon number, you will need to know how to write isotope notation, where any atoms in the periodic table can be represented by isotope notation, or another name for it is atomic symbol. So how you want to write it down? I give you as general, we got X the element symbol, and we got A, this is the nucleon number for element X, and you got Z here is the proton number for element X, and I add extra things that you have to know, which is on the top right, C is the charge for element X, whether the charge is neutral or positive charge or negative charge, it depends on the element that you got. So now, a few things that you have to know, you need to calculate. So this is where a point where you need to use your calculator to calculate the number of proton number, neutron numbers, electron numbers. So please use calculator to avoid any mistake. So now, if you want to know about the neutral atom, as we mentioned, neutral means no charge. So the number of electrons must be the same as number of protons. That's the first point that you need to understand. The second one, when you got charged atom, so the charged atom here means that it's an ion, where in this case we got positive charge and negative charge. For example, for positive charge, when you want to calculate the number of electrons, it means that you have to minus between proton numbers with the number of its charge. Because positive charge, that atom means it donates the electron. So bila dia donate, maknanya electrons dia akan berkurang. Sebab itulah sign yang kita guna dekat sini adalah negative. So that is the second point that you need to understand. The next one is when you got charged atom with negative sign. So how you want to calculate? Opposite to the positive charge, negative charge means you accept electrons. So which means that your electrons is increasing. Okay, so your electron is increasing. So that's why, how you want to calculate the number of electrons? The number of electrons equals to number of proton plus number of charge. So this is the third thing that you need to understand. And last but not least, the calculation for the number of neutrons, as we mentioned before, nucleon number is the total of proton and neutrons. So how you want to calculate neutrons? It means that nucleon number minus number of proton. But please make a correction for this one. This one should be nucleon number. So the nucleon number is the correct term, whereas number of nucleon is the wrong term. So make a correction at this part. Okay, let's continue with a few examples. So I got the first example, which is this is mercury and it's neutral because there is no charge here. So what I'm going to do here, I want to calculate a few things that have been asked usually in the question. So as I mentioned before, I got nucleon number A is 202 for mercury, and then I got proton number 80, which is the symbol is Z. And how I want to calculate the neutrons number, it means that I have to minus nucleon number minus number of proton. So I will get 122 as my number of neutrons. And the next one, I got here the charge, where the charge for this particle, it's neutral. It means that it's 0. The value is 0. But you should know that please don't show the charge for 0 value, because we don't need to show for neutral atom. So if you show it, your isotope notation is wrong. Okay, please avoid that. But you have to know that the charge is 0, but it's only that kita tak tunjuk, tapi kita tahu charge dia 0. And what we're gonna do here, how you want to calculate the total charge? You know the charge is 0, but how? So we know that for atom, the total charge means proton plus electrons. So I got proton, 80 of them, and the charge for the proton is always positive, so I calculate it, I multiply by positive 1. And then I plus with electrons. So as I mentioned in the slide before, for the atom, neutral atom, the number of electrons is same with the number of protons. So that's why the number of electron is also 80. And in this case, the charge for electrons is negative. So I put times with negative 1. So when you total up everything, you will get 0 for the total charge of atoms. So this is how you want to prove whether the charge 0 is correct or not. Okay, let's go to the next one where you want to make the conclusion. Thus, the number of neutrons is 122, the number of proton is 80, and the number of electron is 80. So I hope you know how to calculate these numbers for neutral atom. Now let's go to the atom with charge. So, which means we got ions here. So, I got Mg2+, where 24 is my Nucleon number for magnesium. And I got 12, which is, this is the proton number. So, in order for me to calculate the number of neutrons, I minus Nucleon number minus proton number. I will get 12 for my number of neutrons. And the next one, I got my charge 2 positive. And this is on the top right of my element symbol. And you have to know that when you want to write the isotopic notation, your positive sign must be behind the value, behind the number. Okay? But when you want to write it down, you have to write it as positive sign at the front of number. So I repeat, when you write as notation, the charge positive or negative must be behind the number, as you see here. But as a statement or the answer in your calculation, the charge should be positive sign in front of the number. So how you calculate the total charge for the ion? In this case, as usual, we add up proton number and also electron. So what I'm going to have here, I got proton number, which is 12, and I times with positive 1 because protons is always positive charge, and plus with 10. So how you got 10 here? Because 10 means that electron number for Mg2+, 2+, which means that magnesium donates 2 electrons. So from 12 you minus 2, you will get 10 here. And this is the electron times with negative 1. So you will get the charge positive 2. So when you write it down, positive sign should be in front of the number. In notation, positive sign should be behind the number. So the conclusion that you can say here for neutral number, for magnesium 2+ is 12. For proton number, you got also 12, and for electron is 10. Let's go to the last example. I got negatively charged ion here, Cl minus. So usually Cl minus, we write it down as Cl minus. But in this case, I just want to show you that in front of negative sign, you got 1, value 1. So let's get to the calculation. 36 is my Nucleon number for chlorine, and I got 17 as my proton number. And how I want to calculate the number of neutrons? As usual, minus them, you will get the number of neutrons is 19. So because this is the number, write the number, no units. And then I got the charge. In this case is negatively charged particle, so that's why the sign is negative on my top right for the element symbol, which is in this case chlorine, Cl. And the next one, how I want to prove the total charge, whether I got negative 1 or not. So I total up my proton number and electron numbers. So I will get 17 for my proton number and positive charge for proton plus 18 because my ion here is Cl minus, which means that this chlorine atom accepts extra 1 electron. So I got 17 plus 1, that's why I got here 18, and the charge for electron is always negative, so times with negative 1. So you total up everything, you will get negative 1. And as usual, in the statement or in your sentence or in your calculation, write as the sign before the number, but in the notation, the sign behind the number. Okay, so that's all for the example how you want to calculate the nucleon number, proton number, electron number, and number of neutrons based on isotopic notation. But last, I want to introduce one more example where you got another example in this form. So these figures show you sodium-23, and it asks you to determine subatomic particles for this sodium. So as you know, 23, it means that it shows you nucleon number. So we know the number of the nucleon number is 23. Now, how you want to calculate the number of proton? So number of proton is 11. But where I got this value? So I want to mention to you, this is where you have to use table of relative atomic mass. So this table I already uploaded in Google Classroom, and that table also is being given during the exam. So how you want to find the number of protons for every element? For example, you got this kind of questions, you have to refer to the table of RAM. And once you got the number of protons, can you calculate the rest? Of course, yes. So I can calculate the number of neutrons. I will get 12 for number of neutrons. And because this is the neutral atom, so that's